Hey everyone, welcome back to my series on Terraform Basics. In today's episode, we'll be getting back into data types. We're going to start with the building blocks, also known as primitives. Primitive data types form the foundation for more complex data types. So let's jump right in. Since Terraform 0.12, HashiCorp configuration language and Terraform have supported true data types. Prior to that, Terraform kind of treated everything like a string, and you had to do a lot of manual manipulation and data transformation to get things to work right. Fortunately, that's no longer the case. There are three broad categories of data types in Terraform: primitive, collection, and structural. In this episode, I'll be covering primitive data types. I'll cover collection and structural in their own video. Okay, so what do I mean when I say primitive? We're talking about single value objects that cannot be broken down into smaller pieces. Terraform has three of them: numbers, strings, and Boolean. There's also two weirdo values that I'll dig into at the end of this video. Numbers are simply that. They can be integers, they can be decimals. Either one's fine. When an argument takes a number, say the count meta argument, you can simply put the number as a value. There's no need to quote it. If you're declaring an input variable that is of type number, you set type equal to number. Again, no quotes are necessary. To expand on the previous example, the variable subnet count shown here takes a type number and has a default value of 3. We can use this value in a resource block with the count meta argument, which is also expecting a number value, specifically an integer. The next data type is a string, which is a series of Unicode characters. That means you can use emojis. Terraform is fine with that. Although the cloud you're using might be less accepting, try using an emoji in an Azure storage account name and see what I mean. Strings can get really complicated and probably deserve their own video, so I'm going to keep things high level for this video. Strings can be expressed in a couple different ways. You can use double quotes to construct a string, or you can use Heredoc syntax, which I'll explain shortly. You cannot use single quotes to enclose a string, as Terraform will throw a validation error. A Heredoc string is a way to express a multi-line string. The syntax is to start with a double less than sign, followed by a delimiter. It's typically in all caps, although that's not technically required. After the delimiter, you'll have a line break and then the text that you want to include in the string. When you're ready to end the string, you add another line break and repeat the delimiter. Heredoc is super useful when you need to express a multi-line string, whether that's for a longer variable description or because you're passing a startup script through a user data field. Terraform will apply interpolation to your string, which I'm going to cover that in more detail in my future strings video, but the short version is that Terraform will take whatever you put between the sequence $, curly braces, interpret it, and then turn that into a string. Last up, we have Boolean, which Terraform just calls bool. A Boolean can have two values, true or false. That's it. No need to put those values in quotes either. Terraform considers them first-class citizens, just like numbers. If you want to declare an input variable as a Boolean, the keyword is bool. Like this example here, we have an input variable asking whether or not to create a NAT gateway, with the default value set to false. Hey, those things are expensive. I wanted to put in a brief word about type conversion in Terraform. When passing a primitive value to an argument, Terraform will try to convert one primitive type to another if possible. For instance, if the argument is expecting a bool and I pass it a quoted true string, Terraform will convert that to the bool value without throwing an error. Terraform is trying to be helpful. Terraform will also automatically convert bools and numbers to strings if that's what the argument is expecting, or convert a string to a bool or number if that's possible. So if you submit a quoted 42 to an argument expecting a number, Terraform will do the conversion. But if you tried submitting a quoted taco, that would result in an error. That covers the 3 primitive data types, but I have 2 more oddballs I want to include. Now, they're not actually data types, but a way of expressing a non-data type. Sounds confusing? Let me explain. When constructing an input variable, you can set the type to any, and that means the input variable will accept any data type. Number, string, list of strings, map of lists, you name it. Terraform doesn't even check the data type. When you try to use the variable, you still need to do so with a valid expression. You can't treat a list like it's a Boolean and hope that Terraform will do a conversion for you. Ain't gonna happen. For instance, with this input variable, I can use any of these values. I'll use the type function in the Terraform console to see what Terraform thinks. If I set the value to a number, hey, look at that, it comes back with a number. If I set it to a map now, hey, I get back an object. Any doesn't care what the data type is, but anywhere you actually use the value certainly will. Any is useful when you aren't sure exactly what data type will be submitted to an input variable. This feature was very necessary in the olden days of Terraform, when things like complex objects and optional attributes didn't exist. Nowadays, I think that it should be retired in the majority of situations. The other weirdo is null, which is not a value. It's the absence of a value. When null is used for the value in an argument, it tells Terraform to pretend that that value wasn't set at all. For instance, in this subnet block, the tags argument is set to null. That would be the same as if we omitted the tags argument from the block. Terraform will use whatever the provider default is for that argument. If the argument is mandatory, then Terraform would throw an error. You can set an input variable with a default value of null, assuming you're using it correctly in the configuration. Here's an input variable called common tags with a type of map of strings. For the default, I can set it to null. If I do not pass a value to this input variable during plan, Terraform will pretend that I just didn't set the tags argument at all. This is different than setting the default to an empty map. The empty map is still a value, so Terraform will include the empty map as an argument when working with the provider. For a tags argument, that doesn't really matter, but let's take the automatic upgrade channel argument for an AKS cluster. This argument has 4 valid values: patch, rapid, node image, and stable. The argument is optional, so if you don't set it, the provider defaults to the value none. In this scenario, if I have an input variable that sets the argument and I use an empty string as the default, I'll get back a planning error because that's not a valid value. But if I set it to null, Terraform pretends I haven't set the value and lets the provider use its default none value. Terraform has 3 primitive data types: number, string, and bool. These form the foundation for building more complex data types, as we'll see in a future video. There's also 2 weirdo data types, any and null. Any is a stand-in for when the data type is unknown, and null is the absence of a value for any data type. All right, well, that will do it for today. Thank you as always for watching. Please subscribe and like if you don't mind. Until next time, keep calm and Terraform on. Why, yes, it is a HashiCorp mug. Thank you for noticing.